Well, once again, welcome to the webcast, and let's get started because we've got a lot of great content to share with you today, delivered by some very auspicious guests. And just to frame why Sustainable Minds is into the education marketplace, aligned with our mission about bringing environmental sustainability into mainstream product development and manufacturing, which is ultimately to impact the jobs that we create and the economy in which we live. And I think based on the attendance and based on the customers, the schools who are already using Sustainable Minds, there clearly is a very strong trend to integrate environmental sustainability into all types of curriculum: business schools, engineering schools, design schools, architecture schools. And I believe that the schools are realizing, and it's happening, that those schools who are integrating environmental sustainability into curriculum are attracting more and possibly even better students to meet the demand that industry is demonstrating. And the manufacturers who understand that competing, integrating environmental sustainability into their brand and into their products will innovate and grow, and they will recruit the students coming out of the programs that are readying individuals to participate in this new economy. So with us today, we are really fortunate to have three folks from UC Berkeley: Dave Dornfeld, who is the chair of the Mechanical Engineering Department and the director of the Laboratory for Manufacturing and Sustainability; his colleague Margot Hutchins, who is a research engineer and lecturer and the associate director of the lab; and Cindy Bayley, a graduate student at UC Berkeley and summer intern at Sustainable Minds for 2 summers. And I think you'll be very interested to see how Dave, Margot, and Cindy have evolved their use of Sustainable Minds at UC Berkeley, and how Cindy has brought her experience from working with us over the course of several summers into developing new curriculum for UC Berkeley. The way that we have structured today's presentation is Dave will start out by talking about what's happening at UC Berkeley in mechanical engineering and tell you a lot about the lab. Then I'll tell you about Sustainable Minds. There's a lot of people on this webcast who are familiar with Sustainable Minds and many who are not. And so we'll do a brief overview of the product and the content that comes with the product, so that sets the context for Margot introducing the Sustainable Manufacturing course and starting to give you some insights into the 3 types of projects that they've developed, and 3 types of curriculum using Sustainable Minds. And Cindy will wrap things up with her updated and enhanced version of one of the projects already in the curriculum, and then we'll move to a Q&A. We will take your questions during the webcast. Everyone is on mute, but if you check your control panel, there's a questions box. Type your questions in at any time, and we will take them at the end. Any question that you submit that doesn't get answered, we will follow up with you offline. So without further ado, I'd like to turn things over to Dave Dornfeld, Chairman of the Department of Mechanical Engineering and Director of LMAS. Take it away, Dave.
Thanks, Terry. So we're really pleased to be here and participate in this webinar. As you said, we've got a lot of material to cover, so we'll try to cut right to the chase. Let's see. We're learning how to run the machinery here. So it's interesting. I'm not going to read through all this, obviously, but everyone at Berkeley and its students pretty much in mechanical engineering in most U.S. universities are trying to make things. The designer, the make movement, tech shop movement has come full force. As part of that maker movement, everybody's interested in figuring out how to design products that are more energy and resource efficient, more sustainable, if you will. So it's a great opportunity to have this enthusiasm building on the part of the students, undergraduate as well as graduate students, and of course industry reflects that as well. So I come at this with a manufacturing focus, as do my two colleagues here, meaning that eventually you have to produce products, and eventually there are impacts caused by the production operation, and eventually there are impacts on how these products are used. And we want to try to make sure that when a design is realized, produced, manufactured, that we have taken into consideration, along with the usual quality, throughput, reliability, cost, etc. constraints, issues of resource efficiency and effectiveness. So that's sort of been an area of interest to me for about the last 15 or 20 years, and it wraps nicely over more traditional areas of focus. A little bit of background about mechanical engineering at Berkeley. I think compared to some of the Big Ten schools, I graduated from Wisconsin, we have a smaller program, although its enthusiasm pushes more and more students, about 600 undergraduates. We've got about 370 or so graduate students, and they're all taught and mentored by some 46 faculty members. If you're curious, a POG is a professor of the graduate school, so when someone retires, they can still maintain active involvement in research, not so much in teaching and administration, by becoming a professor of the graduate school. So this leverages the folks who've had a very long and productive career. And we have 22 staff members, of course. Mechanical engineering is something that requires practice, both mechanical, computational, etc., experimental. So those people are very important to keep the place running. The coverage in mechanical engineering these days covers the full gamut, right? I mean, you have, of course, the importance of information technology for systems and sensors. You have biotech, energy, environment, transportation, and then the core areas shown in the very center, traditional areas of mechanical engineering. Berkeley tries to emphasize social impacts to a great amount in the work that's going on, so things that map onto healthcare and quality of life, energy, safety, security, things like that, built on a platform of both science-based and practice-based engineering education. So you can always check it out on the website, but it covers a broad area of activity and reflects a lot of the research going on by industry in the West Coast and the Pacific Rim that we serve with our students and our activities. So I'll talk a little bit about the Laboratory for Manufacturing and Sustainability. It became apparent, as I said, probably 15, 20 years ago when I was on sabbatical in Europe, that companies were beginning to embrace the concerns about resource utilization, energy efficiency, material efficiency, end of life, processing characteristics, safety and security of the employees and their customers and the environment. And it also seemed like this was a good time to go into that from the point of view of what was going to be happening in the United States. Much of it is driven first by energy concerns, and you can map that onto global warming and environmental issues, but there's also, as manufacturing people, the concern about materials and resource effectiveness, utilizing materials in the most productive way so you get, if you will, the largest value for the of a product that's created and manufactured for the impact on the environment or social infrastructure or whatever the area of focus is. So that's what our laboratory focuses on. I also, sort of just to help educate or publicize the comments and get feedback from people, I started writing a blog a couple of years ago with the address is shown there, and that is a place that I talk a little bit more about trying to communicate with a broader range of folks, public, about the interface between technical policy, social issues related to green manufacturing, why it's important. Many people thought, well, manufacturing doesn't have much to do with environmental or green impact, so why do we worry about it? So part of the reason was to try to show people that there is a reason to concern about it. And then there's a Facebook page, of course, social media. I'm not a tweeter yet. I don't think I will be a tweeter, but I suppose that'll come at some point. So to really do this right, one should think about a holistic view, meaning that you would like to say, if you do sort of a Google Earth view of manufacturing, you start at a fairly high level, enterprise, the facility, the corporation, you zoom into a factory, you zoom into a system or a line in the factory, and you zoom lower into that system and line to a machine or a set of machines that are programmed to do certain functions. And on that machine is a process or processes, and the process is enabled by sets of tooling. And the interesting thing is that if you focus on any one of these areas, you can find different and often compelling reasons to green the process or to analyze the energy or resource utilization and see if we can improve upon that. At the same time, of course, while maintaining the requirements of the design process. A lot of this these days, so the cloud is everywhere, right? So data interoperability, communications at all these different levels. So one should take advantage of that, map them onto design tools like Sustainable Minds or more product design tools. And then wrapping around the outside of it, you should really begin to consider social impacts. And this is a tough one for engineers to draw the thin line between when I design a product and I specify how it's going to be made and select material. How do I actually understand the sort of collateral social impacts, whether it's in the factory or it's in my community, or whether it's somewhere in the supply chain, you know, something being mined over in some other part of the world, and if that is being mined in a sustainable fashion and treats the employees correctly, because eventually all of these things get tied together. Companies are being measured more and more on how well they are guardians of the supply chain and ensure that the product that is delivered to the customer is both energy efficient, meets the functional needs, cost effective, safe, but also doesn't cause problems throughout the supply chain. And you know, one can decide how you want to address those things, but ultimately engineers have to make those decisions and figure out what they do at the machine and factory and the system and enterprise and tooling level and how that might have some social impact. That's a complicated one, but that's an area that we're putting more and more attention on because it sort of ties everything together very, very nicely. Just a little bit of a word from our sponsors, if you will. We have a range of projects that we are working on. I characterize them in terms of tools that we provide. Some are technologies, meaning ways in which you can improve manufacturing technology to build energy efficient products or systems, like a project we have funded by DOE on artificial photosynthesis. You have a whole set of analytical or assessment tools or software. So we don't make software, but we like to make modules and define things that fit within other people's software that can help to bring the green assessment or sustainability assessment to the engineer. Or we help define companies' interest in trying to do trade-offs on process technology, which is better or worse if I swap one technique versus another. We look at planning and optimization. A number of companies are working with us on that for the design of systems or design of devices. There's an emphasis on clean tech to some extent, looking at technologies that are specifically clean. And of course, we partner with the campus people on education and with some people in the business school on business drivers. So range of companies supporting our work, developing software and tools and techniques that can be scaled across many different applications. When I started doing this, I tried to build an argument as to why industry should pay attention to the manufacturing part of green or sustainable impacts. The top bullet, of course, is one that a lot of people relate to. There's regulations, there's penalties, there may be tax benefits. But if you think a little bit more deeply about it, and there have been surveys about this that talk about why companies develop sustainable business plans, a lot of it has to do with your competitiveness, maintain market leadership. Increasingly, the consumer, whether it's a company buying your product or it's a John Q. Public or Jane Q. Public in a large shopping center, is looking for companies that they perceive to be more sustainable, better stewardships of the environment, yet delivering a high-quality product that are for a reasonable value. There can be efforts of continuous improvement, right? I mean, saving energy, resources, material is a good way to save money, is a good way to make your process more efficient. So even if you ignored the environmental aspects of it, it's just a characteristic of continuous improvement. You may be using materials that are at risk of disruptions in the supply chain, rare earth materials or some other material that is widely sought after, and that's a concern that can affect your bottom line and your ability to deliver product to the customer. You might want to reduce cost of ownership for your operations. Finally, at the bottom, it's sort of like, you know, what's happening in your supply chain outside of your facility. We've seen some recent examples of things that were totally unexpected in the supply chain that had huge impacts on the ability of the factory to deliver, or the company to deliver product, and also the consumer's perception on how well that company is doing in stewarding their product through effectively and efficiently. So these are all questions that we'd like to worry about. The opportunities that are afforded by addressing these challenges are interesting, and I call them opportunities because they're essentially ways in which manufacturing, again, I'm speaking as a manufacturing person, manufacturing can address the needs. So all of the future energy, transport, et cetera, devices and systems that we're building are based on increasingly precise elements and components, different materials, complicated processes. This is a manufacturing domain. So we need to do this, develop these technologies in order to meet the needs of the future. While we are doing that, we should do it in a way which is energy and environmentally efficient. The customer is asking for it. Manufacturers are asking for it, and, you know, to the extent that it actually comes to the bottom line in terms of the cost of energy or the cost of treating waste or other products as a result of the operation, it saves us money. There's a lot of need for alternate energy systems that are being developed, and in some cases these are benchtop and need to be scaled to full-scale manufacturing to be efficient, so this is great. The machinery that makes things, you know, a machine tool company's customer is a factory and their product is a machine tool. These would like to use less energy, materials, and space. Want to have efficient operation, and of course the government regulations. So this is an opportunity for manufacturing to shine as part of an engineering activity, and linked with design then, as we're going to try to show you that we do here today, how to make the whole system much more efficient. So now I'm going to turn it over to Margot Hutchins, who is going to continue in this discussion and drill a little bit deeper into some of our activities.
Thanks, Dave. So I'm going to tell you a little bit more about our philosophy and how that sort of brought us to this engagement with sustainable mines. So as is likely clear by now, we view sustainability as having three pillars, as I bet many of you do as well: the environment, society, economy. And our goal is to ensure that our engineering graduates are able to address all three pillars through effective design and manufacturing, because there are impacts in all three areas due to the decisions that are made in the design and manufacturing phase. Arguably, because there are more degrees of freedom early in the product life cycle, engineers have the ability to significantly affect the life cycle impacts of products through strategic design and manufacturing decisions. All right. We also strive to contextualize the work that our students will do as engineers. We strive to remind them that the problems they solve are driven by human needs and desires, which also drive political, social, and economic processes. Design and manufacturing engineers provide technological solutions to address human needs, and the technological solutions that are offered, as well as the political, social, and economic processes, impact the human needs and desires and also have some impact, whether that be environmental, economic, or social. I bet many of you are very familiar with life cycle assessment. So this particular slide just outlines the general process that would be used. We try to provide our students with an understanding of life cycle assessment so they are able to understand the linkages between the choices in one life cycle phase, and the impacts in others. Because our focus is on manufacturing, we emphasize how decisions related to manufacturing impact other life cycle phases. More specifically, one of our objectives is to enable students to leverage manufacturing for overall improvements across the life cycle of a product. We hope to provide them with the ability to identify opportunities to make a relatively small investment in the manufacturing stage, which improves product performance and results in decreased impacts. although that investment in manufacturing may create some additional impacts, there are many examples of those impacts being far outweighed by the decreased impacts in other areas of the life cycle. The fundamental concept is connecting manufacturing process parameters to part features and eventually to part function. One of our recent graduates, Munir Halou, uses surface integrity as the example of part feature, and as a subset, surface roughness as an example of surface integrity. Part function is represented by gear efficiency, which is influenced by surface roughness. The process parameter impacting surface roughness is volumetric removal rate. By selecting the correct volumetric removal rate, surface roughness can be improved, and therefore, so can efficiency. By investing slightly more resources into manufacturing, resource consumption during the use phase is reduced. Additionally, we work with students to help them understand how decisions at different levels of the manufacturing hierarchy interact within one enterprise and across the supply chain. And so I think at this point I'll turn it over to Terry for a demonstration of sustainable mines.